As always, I'm going to start by taking the value of x and plugging it into my function. When I plug in 4 here, I get 4 minus 3, which is 1. ln of 1 is 0, so I have 7 over 0. Minus 2 over 4 minus 4 is also 0. So I have 7 over 0 minus 2 over 0. These constant divided by 0, these are for our purposes infinity. So we have infinity minus infinity, which is this indeterminate form, which tells us to get a common denominator. So in order to do that, I'm going to multiply this numerator by a factor of x minus 4. I'm going to multiply this numerator by a factor of ln of x minus 3, and they can share the denominator of those two terms being multiplied. So this is going to give me 7 times x minus 4 minus 2 ln of x minus 3, all divided by the common denominator of x minus 4 times ln of x minus 3. Now that I've gotten that common denominator, I'm going to, x approaches 4 here. Now that I've gotten that common denominator, I repeat this process all over again. I'm going to take the value of x that was given to me, plug it in, and see what I get. When I plug in 4, I get 0 minus 0 over 0, so I get 0 over 0. Okay, 0 over 0 is a form we're familiar with. It tells us to take the derivative of the top and the bottom. So I'm going to go ahead and take the derivative of the top here. The derivative of 7x would be 7. The derivative of 2 ln of x minus 3 would be 2 over x minus 3. The derivative of the denominator, unfortunately, will require the product rule, so it's a little bit of work. I'm going to leave the x minus 4 alone and take the derivative of ln of x minus 3. So it's going to be x minus 4 times the derivative of ln of x minus 3. X minus 3's, or ln of x minus 3's derivative is 1 over x minus 3, so I'm just going to write it like this. Plus, now I'm going to take the derivative of x minus 4, which is simply 1, and multiply it by ln of x minus 3, being left alone. Okay, now we're going to plug in x equals 4 again. And when I do that, I get 4 minus 3 is 1, 2 over 1 is 2, 7 minus 2 is 5. 4 minus 4 is 0, so this is just 0. 4 minus 3 is 1, ln of 1 is also 0, so we have 0 plus 0, which is 0. Now this is 5 over 0. I know before we said that anytime we have constant over 0, that would be infinity, but if we approach 0, if we approach 4 from the right, we get positive infinity. If we were to instead approach x approaches 4 from the left, we would have gotten a negative down here, or a number of a zero approaching very slightly from the left, giving me negative infinity. And so because it's infinity from the right, but negative infinity from the left, the overall two-sided limit does not exist.